ultrasound, and that ultrasound was basically discussed till this point, I think. Yes, is it? Yes, exactly. I told you about the attenuation. That, for example, if we talk about attenuation, attenuation was basically discussed in different ways. That attenuation is that type of yani where the attenuation will take place. For example, if the ultrasound is incident here, it would reflect somehow and it would transmit, and the transmission and reflection both will be correlated with each other. And here we go, that attenuation was depending upon several factors. That was one of them, the mu, and the second one is basically that is the coefficient of attenuation or coefficient of absorption. The second one is the thickness of the medium, and attenuation as an exponential decrease. So this medium, that red, blue, and green, all the ultrasound has passed through the same thickness, but attenuation in the medium one is low, so its curve is little smooth, not that much steep. Then second one has a little bit medium attenuation, and third one has the highest attenuation. So in this way, the attenuation increases with the medium. So here we go. When we talk about the attenuation, I is equals to I naught e power minus this. So this is basically mu. So I told you that if mu is in centimeters inverse, then thickness will also be. So no need of conversion at all. So we can calculate this, that what amount of intensity will be attenuated and how much will be released. So the finally I told you about that, basically here the intensity I naught is incident here, some of that is transmitted, some of that is reflected. So at this boundary you people are supposed to calculate or use the attenuation coefficient, sorry, yeah, the reflection coefficient. Basically the reflection coefficient means that the energy of the ultrasound will be dissipated due to reflection at this boundary. This is the boundary where attenuation will take place, where the decrease in intensity will take place due to reflection. But when the medium is here, the ultrasound is passing through this all, then you will use the attenuation formula. What will you use? You people will use attenuation formula. So by that one we will be moving further, and when we will reach to this position, again some of that is reflected, some of that sound is transmitted. So here again we will use the coefficient of reflection. So when reflection is involved, you will use this formula, IR divided by I naught equals to Z1 minus Z2 divided by Z1 plus Z2. And when attenuation through that medium is required, you need this all. So by this way we came to this topic. Yeah, so today we will be discussing the generation and detection of ultrasound, how the ultrasound is being generated, and how do we detect the ultrasound. So with ultrasound is basically generated by using a piezoelectric transducer. This is a name for that transducer, that is piezoelectric transducer. The function of that transducer is that it works on the principle of conversion of mechanical energy into electrical and electrical into mechanical. So first of all, when the ultrasound is produced, it converts electrical energy electrical energy to mechanical energy, and then mechanical energy is again converted into the sound energy. Although sound energy is one of the is produced due to mechanical vibration, but that happens. Now what do we do? This is a quartz crystal, and that crystal is actually um, supported by, or that quartz crystal is um, sandwiched between two electrodes, cathode and anode, and that cathode and anode are connected with a high frequency, or the frequency of the ultrasound which we want to produce, the alternating power supply with that one, yani frequency generator, simply I can say. So when the frequency generator which is producing the electrical signal at this frequency, that signal is applied to this, so due to that it causes compressions and rarefactions. So due to that compressions and rarefactions, when yes, there is one more thing I want to explain to you here. Do you know there is an electric field developed here? Due to that electric field, due to this electric field produced here, they would be coming closer, these plates will be closer to each other, then they will be moving away, closer and away. So in this way the compressions and rarefactions are produced in that medium in which it is performing this vibratory motion. So simply speaking, if I have the compressions and rarefactions, so definitely that is the longitudinal wave. So these compressions and rarefactions are sent in the form of pulses, not continuously, they are sent in the form of pulses. So that is why the doctor just uses this ultrasound transducer on the body, moving. Then here a pulse is generated, here, all these pulses are sent, and meanwhile when the doctor brings it back, the ultrasound pulses reflect back through the body and they come back to this receiver. And during this receiving process, what happens basically, when these compressions are reaching to this transducer, again the electric field is being changed, and due to that the electrical signals are produced, and with the help of that device, or with the help of an amplifier, they are basically fed to the processor, and processing machine converts those signals into some images. So the important thing what I mention here, that is the memorization factor. You have to memorize these all for 6 marks. What is that? The working principle of ultrasound. Working principle of ultrasound. But the working principle of ultrasound is asked to you by all means. So ultrasound is the sound of frequency. There are several points. You can write some of the points in that. Right? For example, the ultrasound is a sound of frequency 20,000, greater than 20,000 hertz, and produced by a quartz crystal due to the piezoelectric effect. And this is very simple thing, that this first part in the first principle mean some of the characteristics by which we can perform the ultrasound imaging. So in first point, what I have explained, or what I have mentioned, that is the property of ultrasound, that it is the ultrasound with the frequency greater than 20,000. Secondly, how it is being produced with the help of a quartz crystal. Third, that quartz crystal works on the principle of piezoelectric effect. So 3 informations are blended here in point number 1. So I will request you all that please go through all these points in the same way as I have mentioned here. Secondly, the pulses of ultrasound are sent to the body or to the sample through gel. Here I have mentioned the procedure, that pulses are sent, right? Pulses are sent to the body, and here I have mentioned that yes, why are the gel is important. Gel is important. You can even write through gel to enhance or to increase the intensity of transmitted ultrasound. Okay, so you can write in that way. Third factor, now I'm explaining that how those pulses come back, or how those pulses basically proceed into the body. So this all is very sequential. If you remember this is very sequential. The pulses reflect from the boundary of the sample, and they are received by the same transducer. Remember this thing, same transducer. They are reflected from the boundaries or boundary of the sample and received back. Now this is fifth, fourth and fifth is basically its quantitative analysis, that the intensity of the ultrasound pulses depends upon the acoustic impedance of the medium and the interface nature of the interface. The intensity received pulses tells us about the nature of the sample. If more ultrasound is reflected back, it means there is a different z, or there is a difference in the z. But if it is received back with the same intensity almost, so it means its coefficient of reflection is almost same. Oh, sorry, acoustic impedance is almost same. The time delay, there are two very important. Point number 6, the time delay tells us about the thickness or the depth of the sample. Again, very important, right? I'm just at that point, that what does that image show us? Okay, that the intensity tells us about nature, and the time delay tells us about the depth or thickness of the sample. Here at seventh point, what I have told you there, the gel is used to decrease the reflection from the skin and to improve the penetration of the ultrasound in the sample. So these all 7 points are very important. Now the final point is basically about the image production. The received pulses are provided to a computer or a machine, and they are displayed after being processed. It's very sequential. I told you, first how to produce ultrasound, second how to send ultrasound, third how ultrasound pulse travels through the body, fourth how do we receive it back, fifth what does that received pulse tells us about, yani intensity and time delay, seventh and eighth, seventh and eighth, that received pulse is basically processed by the machine and displayed on that. So this is the most important 8 points, I mean the summary of the ultrasound. Okay, is it clear to everyone? So here I have used a technique, the imaging of ultrasound. When we use imaging of ultrasound, I mean that ultrasound give you two type of scans. Scan number 1 is that in which the graph is on one plane. Here the graph is only on one plane. One plane graph means you have y-axis and x-axis. Sorry, two plane graph, y-axis and x-axis. On y-axis, this is the intensity of the X-ray ultrasound, and on x-axis this is the time delay. Okay, this is the time delay. So when we receive pulse number 1, that is the highest peak, means its intensity is highest. It is the first reflected pulse. Then the second peak is the second reflected pulse, third reflected pulse, fourth reflected pulse. So basically here below I have mentioned that, yeah, when you apply the ultrasound transducer on the gel, some of the intensity is coming back to you from the skin, next is coming back to you after traveling this distance, next comes to you after traveling this distance, the next after this distance, and so on. So everywhere the ultrasound is echoed, ultrasound is reflected. That is why, what how do we mention the depth? Actually the depth is speed of ultrasound into time divided by 2. Yani I use this formula, v is equal to d by t, but this d is either twice of that separation, or the time is half of the time. You it's your choice, whatever you use, but the depth is calculated by vt by 2. Vt by 2, speed of ultrasound in that medium into time between these two pulses, this is usually a reference pulse that we receive the signal at this one. And then this all is used. There v is the speed of the ultrasound in the medium, t is the time delay between two pulses, and d is the depth. And b scan is a sonograph. So sonograph is basically a sort of uh, 3D x-ray, to somehow we can say. In that, the x-ray machine is not fixed, it is just revolved, just like over body x-ray ultrasound. It is just moved around the body at different positions. The ultrasound is sent, then it is sent from here, and so on, so on. Then it comes back. When it receives back in this position, that is why the receiver receives that back. And this is the thickness of that sample. Like, for example, if a patient is having a kidney stone, then this entire sample will be a kidney, and in that there will be a stone. So usually you have seen that, oh yes, it has this much thickness, this much length, and all that. So we can give the size of the uh, sample by this sonograph. So this was basically all of my ultrasound topic. I hope that this topic was quite easy topic, very topic based on your observations. Now I will open up the worksheet before switching to the X-rays topic. I will try my best to solve some of the questions for you from the ultrasound, and then that topic will be solid. Okay, so here is the worksheet, and I will try my best to make you clear as much as possible from these all questions. This worksheet is uh, not from complete medical physics. This is just ultrasound worksheet. State what is meant by specific acoustic impedance of the medium. Yes, we have discussed about that. So what would it mean? Yes, Taha, can you tell me please? अच्छा, जुबानी याद नहीं हुआ अभी? Okay. Okay, the that is the product of intense speed of the sound in the medium. The product of, okay, let me select a color, good one. Okay, that is fine. The product of speed of sound, speed of ultrasound, you can say, in a medium and its density, yani density of the medium, yani that was basically Z, and it is rho times C. Now do you remember? Now is it clear? Okay, next one, the intensity of the reflection coefficient alpha is given by the expression alpha is equals to z2 minus z1 minus divided by z2 plus z1 whole square. Explain the meanings of the symbols in this expression. Alpha, what was that alpha? Alpha was basically the coefficient of reflection, isn't it? Coefficient of reflection of intensity, coefficient of reflection of intensity, or you can say the ratio of reflected intensity to the incident intensity at a surface of medium, or at an in boundary of a medium. The best thing is at the boundary of the medium. Okay, What it? What about Z1 and Z2? The acoustic impedances of are specific acoustic impedances of, yes, both mediums. Okay, is it clear to everyone? Okay, now this is that question which will help you out in some sort of calculations. But in the calculations, if you see, yes, sorry for this inconvenience. It is basically I have saved, I think, while editing. So a parallel beam of ultrasound uh, of intensity I naught that enters in the muscles. The beam passes through the thickness of 3.4 centimeter muscle before being incident on the boundary with the bone as shown in the figure. Here is basically 3.4 centimeter thickness of the muscle, and then it reaches to the entering at the bone and so on. Now the intensity of the ultrasound beam as it passes into the bone is IT. Some data of the muscles and the bone is given to you. Here, the linear absorption coefficient per meter, as I told you, the unit will be given to you. 23 is for muscles and 130 is for the bones. And the specific acoustic impedance, I use this word, specific acoustic impedance, that is given to you. Yani you can simply say this is your mu1, this is your mu2, this is your z1, this is your z2. Now let's move to the question. What you have? Oh my god, 5 marks question and direct question. Calculate the ratio of IT to I naught. IT to I naught. Yani I have to draw this diagram for you. Here I'm going to draw this diagram simply because I have to perform some calculations as well. Okay, so that is why. Let's say this is the medium change takes place here. Okay, now at this level the ultrasound is entering here, it's I naught, it is reaching here a little bit, I mean a little different value. It is, some of that will be reflected back, some of that will be passed through into the bones and so on. So is it, do you believe this thing? This is basically the given in the diagram. Yeah, this is basically that ultrasound which is entering through the muscles. Okay, this is the ultrasound which is entering through the muscles, then it crosses those muscles, then it reaches to this point, then it reflects back, and then it passes into the bone. So IT is that which is entering in the bone, and I naught is that which is entering in the muscles. So I have to calculate that all. So let me write this here. This is your I naught, this is your IT, but in between, let's say this is your I1, this is your I2, and now I will be moving towards this, the solution of this question. But what is the thickness of this muscles? That is 3.5, I think, 3.4 centimeter. How much thickness does it have? 3.4 centimeter. And what is mu for the muscles? That is 23 per meter. This is important to mention, per meter. Okay, now my journey starts for the calculations. The journey starts in this way. First of all, what do you think? The ultrasound which is entering here, will it be reflected or attenuated through muscles? These are the muscles. This is bone. So I told you that the ultrasound would have reflection only where interface is there. So here is that interface. Otherwise it would have attenuation. So I will simply say that in the muscles the attenuation is taking place. So due to attenuation, I2, I2, where is I2? Here is I1. Here is I1. So I1 will be attenuated intensity as compared to I0. So I simply say that I1 equals to I0 e power minus mu times x. So I will use this value I1 equals to I0 e power minus 23 times value of x is 3.4, but I have to convert that into meters, so I will just plug it in this way. So from here I will get I1 divided by I0 equals to, yes, please give me the value of this all. This all. Okay, I'm waiting for your calculations, please. Yes. 0.46. Good. So did you get this, everyone? Hello everyone. This is your attenuated intensity which is reaching to the interface of bones. Now at the bones what will happen? There will be a reflection at bones. What do you think? What is going on in the bones? At bones, I1 is partially reflected and partially transmitted. Is it? Is transmitted as I3, as IT, as IT, because I have to use this notation, and I2 is reflected back. So if I just draw that diagram for you, that this is the muscles and bones boundary. So from that boundary what will happen, some of the waves or some of the intensity would be, here is that I1 which is reaching to this point, I1 is which is reaching over here, and if this is I1, that will be basically, yeah, this is I1. Sorry, this arrow is a little bit big one, so I have to use it here. Out of this some is transmitted back, some is reflected back, sorry, not transmitted back, some is reflected back. Let me draw that with the help of arrow. This is reflected, which is I2, because incident was I1, and rest is transmitted. So beta, here what I am going to apply, that is very important thing, that I will, yani during exam definitely you are not supposed to give all these details, but here because I am in exam with my students, not the examiner, that is why I have to give you every detail here. So here is reflection. So do you know how to calculate reflection? Reflection is IR divided by I1. Are you getting my point? So sorry, IR divided by I0. So what is IR here? IR is I2, and what is incident intensity here? Incident intensity here, that is your I1. So here it would be I2 divided by I1 is equals to Z1 minus Z2 divided by Z1 plus Z2 whole square. So can you please help me out to calculate this value? Z1 1.7 and 6.3 values are 1.7 minus 6.3 divided by 1.7 plus 6.3, 10 power plus 6. From the numerator and denominator it would be cancelled out, and here it would be squared. So please help me out to calculate this. IR divided by I naught, that equals to 0.33. Okay, so this 0.33 is basically that ultrasound which has been reflected. But my task is not the reflected only. What is my task? My task is the transmitted, because I want to reach at the transmitted. So this is your equation number 2. This was equation number 1. So do you know what is that? The transmission and reflection intensity means, yani here I transmitted plus I reflected, that is equals to I naught, na? Is it? We studied that the total intensity will be equals to what? Total intensity will be equals to the sum of transmitted and reflected. So what is the total intensity at the muscles and bones interface? This is I1. Out of that, IT is transmitted, I2 is reflected. So I1 is divided into I2 plus IT. So beta IT is equal to what? IT is how much? 0.13, yeah, you can say, but it will be I1 minus I2. Okay, but you do not have direct values. So what I have to do, I have to divide these numbers by I1 on both sides. Divide these numbers with I1. Actually, there was a trick for this all. I told you about that trick, if you remember, that alpha plus beta, that equals to 1, and alpha plus beta means that basically alpha is 0.33, beta is to be calculated, and 1 is total. So beta is equals to 1 minus 0.33. So what did you get? This is 1 minus alpha basically, and this is beta. Beta is IT divided by I1. So it is 1 minus 0.633 means 0.63, I think so. Is it? 0. कितना? 67? 67. Okay. Now after this all effort, I got this third ratio. So beta, now what is your task? As I told you, this is 5 marks. So examiner actually means those 5 marks. It does not that okay, you are just awarded these 5 marks without any effort. No. Here the situation is now in your favor. You people are going to make it in simple words that I have to use IT divided by I naught. This is my task. As I told you that for these type of questions, what you have to do, you have to go a reverse way. Reverse way means करना ये है कि IT is basically a factor of, or IT is coming out of I1, I1 is coming out of I naught. So yes, you can go in this way in the reverse order. So here we go, because I have IT, I have to figure out IT. So beta IT divided by I naught can be written as IT divided by I1 into I1 divided by I naught. So if I use these two equations by chain rule, so can I use this, or can I do that? What is IT divided by I1? IT divided by I1 we have calculated in equation number 3, 0.67. So 0.67 times, what is I1 divided by I2? I1 divided by I2 is calculated, sorry, I1 divided by I naught, that is calculated in your equation number 1, 0.46. So that means I will apply that here, 0.46. So can you please calculate these two for me? It is IT divided by I naught, that is equals to, yes, multiply them both.
Sir, I got 0.31.
0.31. Got it?
1.
Sorry, can you repeat please?
Sir, I got 0.31.
3-1 na?
Yes, sir.
Okay. So this is basically the final solution after this all discussion, that this means ultrasound. Got it? Is it clear to everyone?
Yes, sir.
Okay. So we have to, we we have to take it serious, actually, what I mean to say. This is question number 2, same question, same practice. So I will send you this worksheet with this solution also. So I hope that you people will practice rest of the questions with from that worksheet in your time. Okay.